In this video, we're going to describe how to express an area between two functions with an integral. So we know that the area between the y-axis and a curve above the x-axis is given by an integral. But we can actually look at any two functions and look at the region in between them. For example, here's a function, and there's another function. And if we're given some particular x values, which will be the limits of integral a and b, then we can figure out what the area is between these two graphs. Suppose the graph above is called f and the graph below is called g, and we want to find the area between f and g lying between x equals a and x equals b. In other words, we want to find this area here, well, the basic idea is that we can approximate this area with little rectangles, as we did before with the area under a curve and above the y-axis. Approximate with little rectangles. And the size of the rectangles is given by the change in x, which is dx, and then we have the height. Now what is the height here? Well, that's the distance between the curves. Now if f is the curve on top and g is the curve on bottom, then the height at any particular x value is going to be f of x, that's the height of the curve f, minus g of x, that's the height below. So the area of a rectangle, say this particular rectangle, is going to be this height, f of x minus g of x, times dx. And then we have to sum that over all the different rectangles. So by summing, we take the integral. So we have the integral, and we start, the very first rectangle starts at a, the very last rectangle starts at b. So we have the integral from a to b of f of x minus g of x times dx. So this is the area between the curves. It's very important that in this case f is larger than g, because we want this to be a positive number, and so this better be positive, so f should be larger than g for this. If g were the larger function, then we want g minus f of x. That would give us the height, if g and f had their roles reversed. Okay, so let's see an example. Use an integral to express the area between the graphs. Well, the first graph of, say, y equals 10 times e to the x, and y equals x plus 1, for x, we have to know where we're going to start. So x between, say, 0 and 5. Okay, so we want to use this basic idea. Again, we have two graphs. One is given by 10 times e to the x, and one is given by x plus 1. Now we first have to figure out which one is larger, which is the larger function, and we have to do so over this interval 0 to 5. Well, this is an exponential function. At 0, the value is 10. At 0, the value here is 1. So at the beginning, at least, 10 times e to the x is larger than x plus 1. At x equals 5, certainly this is growing very fast. And at x equals 5, it's going to even be much bigger than what happens here, which is 6. E to the 5 is huge. This is growing exponentially, this is just growing linearly. So because this one is larger at 0 than this one, we expect that, in fact, that'll continue. And so we expect that 10 times e to the x is larger than x plus 1 on this interval. Now, if you're not sure, you can always graph these two functions with your calculator and just check which is the larger function. So you can graph them on the same set of axes using your calculator. If you did that, then you probably see a graph that looks something like this. Here is x plus 1, has slope 1, it's a line, and then 10 times e to the x, well, that would be way up here. It'd be something that might not even see it if you don't set your calculator to have a large enough y window, but it's much larger. So we're going to be finding an area between 0 and 5, so we're going to be finding an area involving this, if this is 5, say. So we're finding that area. Now how do we do that? We just use the handy-dandy formula up here, which says take the larger function, subtract off the smaller function, integrate between the two endpoints. The endpoints here in this case are 0 and 5. So what do we get as our answer? We take the integral from 0 to 5, because that's where we start. X equals 0. The endpoint is other endpoint's 5. Then we take 10 times e to the x, and we subtract off x plus 1. Don't forget to use parentheses around the second function, because you want to make sure you subtract off both the x and the 1. Here's our f of x, 10 times e to the x. Here's our g of x, x plus 1. Then we multiply by dx. Okay, so that's an expression for the area between the two curves. If you want to actually figure out what the integral is, you could actually use your calculator and get an actual numerical result, an approximation of what the area is.